is a developer advocate for the Google Cloud Platform. Ray is also a DevOps guru. Has built a number of applications for a number of different companies, worked on a lot of open source projects, and likes photography and traveling.
Yeah.
So, go ahead, Ray.
All right, thank you very much. Thank you. I hope you're all applauding at the end of the talk as well. Yeah, just saying. Cool, so this talk is going to be gRPC 101. Now, what I learned yesterday is that 101 is not a common concept in Europe, apparently. 101 just means that it's the first university session, an introductory course kind of thing. And my name is Ray. I'm a developer advocate for the Google Cloud Platform. And if you have any questions about today's talk, please contact me at Twitter, on Twitter, at @SaturnIsm. That is my Twitter handle. If you don't like the talk, please contact me on Google+, because I don't think you will be using it. So, just kidding. No, I hope you do. No, I'm just kidding. If you have any good or bad, just let me know on Twitter. All right. Aside from developing applications, being a developer for a long time, and did a few architecture-related work, project management and all that, but my other passion is definitely just traveling and photography. So if you want to see some of the places I've been to, check out my Flickr, also under the nickname Saturnism as well. Now, I have a lot to talk about today, so I'm going to breeze through some of the introductory stuff and then jump into some of the code to show you exactly how this works. And the reason I wanted to do this talk as well, which I constructed, is because that there's a trend of microservices, right? I'm not going to go into any of the theories or whatever, like what you should be doing it, what you should be doing it. But if you do want to, say, create a microservices application, or if you do want to develop any sorts of distributed systems, one of the things that you're going to realize really, really quickly is that we're going to be breaking down like a single application, potentially, that we traditionally do, into multiple ones. And there are consequences for doing this. So you need to know why you need to be doing this in the first place, right? And also the consequences are potentially you need more DevOps, you need more ways to manage and being able to deploy and monitor these different individual instances of your application or your services. You need to provision for them and such. But there are a lot of worries, but there's one thing that people often miss is how do you communicate between the two services, right? How do you actually do that? And I think today, most of the times, we kind of fall back to, well, let's use REST, right? It's JSON over HTTP, it's well known, and that's kind of the default choice today. But be careful though, just because, remember, 10 plus years ago, where some other technology was the default choice, and you also have consequences for those as well. So I want to show you something new, hopefully something you'll like today as well. But then you may be saying, RPC, that sounds a little familiar, no? RPC's been around for a long time. I don't know, anyone here used Corba before? Anyone? Yeah? You loved it, I think. So just for the research for my talk, I've done this a long time ago. But I found this great tutorial. It's a really good tutorial on how to use Corba. Let me just make sure you can see this. Right? First off, with most of the RPC frameworks, you're going to start off with the IDL, like interface definition language. This is so that you have something intermediate that's language agnostic, but then you can use this interface definition language to generate code for many other languages, right? So that's pretty straightforward. We have, in this example, there's an app. You do addition for 2 integers, okay? Just 2 longs. Just keep that in your mind, just 2 longs. Okay, and then you generate the code. This is a tutorial for Corba, right? You generate code, you have the stuff, and then you implement the operation, right? That's pretty straightforward too. Yeah, not bad. It's just one method. And then what got me is when you want to implement the server. And, and just to add 2 integers together, this is what you have to go through to start the server, which I just got completely lost, all right? And then if you scroll down a little bit more, this is a great tutorial. If I ever need to do Corba again, this is the tutorial I will look. And then this is what I need to do to generate the client or to use the client. And again, there are a number of things here that I don't understand. For example, narrow anymore, and naming context and all that stuff. So that was the state of art for RPC. No wonder, I guess, nobody really think about RPC anymore. And then there's DCOM, there's RMI, which is great for Java developers. But the problem is, well, first of all, you can create Java code, right? You can write interface, you can write implementations, you can expose them as a remote, service, and then you can just invoke it. It's really nice, it's really easy to do. However, it is not so interoperable, right? Even though it's so easy to use, you can't really interop between different platforms, different languages. And then somebody had an idea of, well, wait a second, why don't we just use XML for the interchange, right? For the messaging format, it's machine readable and it's human readable, kinda as well. And then we have this thing called SOAP, which we can do both styles of remote codes. You can do document style codes. You can do RPC style codes as well. Regardless, well, we came a long way, right? Now today, the state of art is JSON over HTTP or RESTful services in most cases. But why would you even consider RPC after what I went through in the past couple of minutes? Well, think about this. First of all, RPC is hopefully, or definitely, going to be a little bit more efficient than, say, JSON over HTTP. Why? Because in most cases, they are going to be binary. They're binary protocols, right? So I remember years ago, people are saying, well, SOAP is too slow, XML too slow. Well, guess what? Anything with text is going to be too slow for you. So that's why RPC still has a place in the world, because they are mostly just going to be binary messaging. They are strongly typed because you define everything through the IDL. It's strongly typed across multiple languages, unless if you use something else that you cannot do typing. I don't know want to mention which one. And then think about this. For the RESTful services, most of the times you operate on a resource. And you are limited to kind of the semantics of the HTTP verbs, which are the get, the put, the patch, right, the delete. They're mostly CRUD operations. Now, if you want to implement some more complicated business processes in a remote procedural call, for example, or via JSON over HTTP, right, how would you actually do it? Suppose you need to transfer money between two accounts, right? What is the right verb to use for that? How do you actually implement a RESTful service for that? In RPC, you can simply define an operation that says transfer, and then take in two parameters, and that will define the service. So RPC can, in my mind, can only be great. It was great, but it can be better and be great and being used today only if it's simple to use and interoperable between different languages. And that's where gRPC comes from. Now, at Google, we actually use an internal framework called Stubby. Stubby is our internal RPC framework. It's used for just about everything for remote procedural calls. And we handle about 10 to the 10 RPC calls per second with Stubby. It was made to be very, very efficient. Now, just imagine if we need to make that 10 to the 10 number of calls with REST or anything else. It may not be as efficient, right? Not only that, if it just takes 1 byte bigger in the message size than is necessary, we're looking at 10 to the 10 more bytes that we have to transfer across the wire, right, across the data centers. And what happened is that Google wanted to open source Stubby, and another company called Square was trying to make the next generation of their RPC framework as well. So I think what happened is that, well, I heard this, what happened is when they joined forces and they said, well, why don't we just open source this Stubby thing altogether and call it gRPC? And that's where gRPC came from. It's actually coming from the best practices of both companies in a way. Now, the gRPC is fully open source. The G in gRPC does not stand for any companies I know of. It is a recursive acronym. It's gRPC Remote Procedural Call Framework, okay? It is simple to use, which hopefully you'll agree. It generates idiomatic bindings for the languages. It is definitely performant and scalable, as we saw in the past slide, and it's interoperable and extensible. The underlying technology that's being used are also open source, or they are standards. For example, for the IDL, it uses protobuffer3, which is another open source project from Google. And the payloads are all binary, and there are, of course, protobuffer3 payloads as well, which is made into efficient binary payloads. The underlying transport between services is using HTTP2 rather than HTTP1. Now, why is that important? Well, HTTP2 is also a binary protocol. So Number one, what happens is then you don't spend a lot of bytes on just describing the verbs, right? The get, the put, the patch, whatever. The headers are being compressed for you. Okay, in HTTP2, header compression is there. So rather than spending, again, a lot of bytes just to specify all of your headers, they're all going to be compressed for you as well via the algorithm called HPAC. The strings are multiplexed. So in HTTP1, what happens when you need multiple connections or strings? Well, you open multiple connections or you do pipelining and such. Well, in HTTP2, the multiplexing is default in the transport. So you can multiplex multiple streams, so you don't have to open up multiple connections. And I said the word string. Streaming is also default and native in HTTP2. So rather than dealing with WebSockets, you can actually do client to server streaming and server to client streaming and bidirectional streaming as well. And that's all built into HTTP2. Okay? And just to show you what that feels like to be on a binary protocol, here is a demo page. Okay, so if I have internet here, so that's HTTP1, which is loading 200 small images, and that's HTTP2. But here is I guess FOSDEM is really fast here. Yeah, but yeah, there you go. So on average, you can definitely see HTTP2 is going to be much faster. Now, another really neat thing is the server can actually push data to the client before the client even asks for it. Now, that's really cool. Just imagine you're in a situation where, well, the client requests like index HTML, and you know for a fact that they need like a CSS and all these other things. Well, guess what? You can just push it to the client before they even ask for it. Okay? Now, it is a binary protocol, so of course we expect it to be faster. So this is a comparison that they have posted on a public blog, actually, the throughput comparison. And with the same machines, you can see that, obviously you can get more throughput. But what is more interesting to me, though, is the throughput per CPU. Okay? And that's important because we're quickly moving into what people call a cloud-native world. And that doesn't necessarily mean you run on the cloud. But what that means is you want to be as efficient and nimble as possible for your services. And with gRPC, you can process more with less CPU. Now, what that also entails is that if you do run this on a mobile devices or smaller devices or IoT devices, well, it's going to be more efficient as well. Supposedly, hopefully also use less battery for the same amount of data you're trying to transfer. Now, I want you to focus on the languages that the gRPC can support. A number of them. My favorite is Java here. But I want to focus you on 3, which is Objective-C, C#, and Java. That's because these 3 languages are being used in mobile devices as well. gRPC was made with mobile first in mind, right? So you can use gRPC on the client side from these mobile devices, whether it's an iPhone or iOS or a Windows phone or an Android phone. Okay. So let's see it. Let's see how much time I have. I got 30 minutes. Well, great. Okay, so with gRPC, what I'm going to do, first of all, I'm going to implement a very simple client-server thing so you just get a feel. And then next, I'm going to do bidirectional streaming with a real-time chat application with gRPC. And I'm going to, hopefully, I'll do that within the next 20 or 30 minutes or so. All right, hopefully, I said. All right, so with gRPC, the first thing I need to do is to use the IDL to define your payload and your services. And these files are going to be called the proto files because they are protobuffer3 definitions. And to make sure we're using protobuffer3, we need to first say syntax is proto3. Okay. Now I see a lot of many hands who are Java developers. It's okay if you're not, because hopefully the simple will make a lot of sense. But in this IDL, it's universal for all languages, right? And just like in Java or in many other languages, we have the concept of a package or a namespace. So what I can do is I can say, well, let me put it under this package, right? So all the payload, all the services is going to be generated under this type of package. This file is going to be processed by a generator, right? Basically something that generates the actual source code, the stubs. And that generator can take in different options. So for example, I can say something like option, Java, multiple files is equal to true. What that means is Well, by default, it's going to generate all the classes into a single giant Java file, right, with everything inside. You can specify options for the generator, and this specific one just says, well, for any of these payload and services, let's generate a different Java file for it. Okay? So that's how you kind of set this up. Now, the next thing you do is to define the message. Okay? And the syntax is pretty straightforward. You just say message, and I'm going to say hello request, for example. gRPC is just working based on the operation and the request and the response. Okay? And in this request object, or payload structure, whatever you want to call it, you can define multiple attributes. So for example, I can say string is equal to a name field, and I can assign it a tag. Now you can see here it's strongly typed. The name of the field is right here, but then you assign it an integer tag, right? That's because this tag is actually going to be the bytes that get sent across the wire to identify this field uniquely within this message payload. So rather than sending the string, that's name, we're just sending the byte over, okay, or however it takes to send the integer over, okay. So I can strongly type everything here. So I can say age is 2, for example. I can even do enumerations or enums. So for example, I can say enum is sentiment. That's how good we're feeling today. I'm feeling pretty okay, so I'm gonna say happy is equal to 1. Let's see. It could be a little sleepy right now, which I hope not, but I saw somebody yawning. But so sleepy, I'm gonna say sleepy is equal to 1. Happy is 0. And then by the end of this talk, you might be extremely angry at me, so I'm gonna say angry is equal to 2, right? So once you have defined this enum, you can say sentiment is equal to 3, right? Again, don't get messed up with the equal signs because it's just saying the tag is equal to 3, right? You can do, if you need a list of things, you can use the keyword repeat or repeated string. And I'm going to say hobbies is equal to 4, something like that. And you can also do strongly typed maps or just hash tables or something like that. So I can say map, and I can strongly type the key and strongly type the value. And I'm going to say bag of tricks equals to 5. Okay. Now live coding is definitely not my bag of tricks here. All right, so so you can do all of those, right? Pretty straightforward. And I can do the same thing for the response. String and greeting is equal to 1. Now the tags just need to be unique within the message payload itself. The next thing then I can do, once I have the request and the response, then I can define the services. So I can define a service called greeting service, for example. And here I can define the operations, the RPC calls itself. So here I'm going to say greeting, and I'm going to taking a hello request. And I'm going to returns hello response. Okay? And that's it. That's all I need to do to define this interface. Now, in gRPC, you can do streaming as well. You can do bidirectional streaming, client side to server, server to client. And that's because we are using HTTP2 behind the scenes. To make something streaming, all you have to do is to add the keyword stream, and that's it. So in this case, if I add the keyword here, that means, oh, this is a client-side stream. So imagine if you have devices that need to stream metrics to the server, well, that's probably what you would do. You just say client-side stream. If you want the server side to stream responses back, like in a chat application, then you just put the stream in the response, and that becomes a server-side to client-side stream. Okay? All right. So now that's all good. Now, next thing I need to do is to generate the actual stubs. Okay. Now, the generation of these stubs is a little bit different across different languages, but there are tooling for it. Now, in Java, I like to use Maven, so you can use a plugin in Maven, or if you're using Gradle, you can use a plugin in Gradle as well. So what I can do is go to the gRPC page. So here is the gRPC source code, gRPC/gRPC Java, and they got different ones for different languages as well. Now, if I scroll down, they got instructions here. So for example, I can add in the dependencies. I'm going to do this fairly quickly, dependencies. Okay, and then I'm going to add in the build plugins here. Now, that's Maven. Don't be scared. If you're in Gradle, you can see it's slightly easier, right? All right, it's really up to you on what you want to use. Okay, good. Now let's, sorry, let me just go ahead and do Maven clean. And let me do a Maven package. So what happened now is that the generator is tied into the packaging phase or the compile phase. The compile phase of the cycle. Now, what's interesting here, though, is that this plugin actually downloads the right binary for your architecture. So if you're on a Mac, it's going to download the Mac version. If you're on a Linux, it's going to download the Linux version of the compiler, the gRPC compiler or the generator. Okay, different platforms needs a different binary. But they really made it easy for Java developers to get started as well. Okay, so that's good. So now if I see target, I should be able to see generated sources. And here I got protobuf, and I got Java. And here, you can probably see it. I have the request and the response generated. This is kind of expected, right? And let's go ahead and implement some of these things. I'm going to write about 300 lines of code. No, I'm just kidding now. So first of all, I'm going to create an implementation class. I'm going to say greeting service impl. No, please don't add it. And no, how do you zoom in here? There you go. Okay. So in this class, what I want to do is to extend, for example, the stubs. And you're probably going to be doing this for most of the languages as well. So I'm going to say extend the impl base. And then I just have to override and implement the method itself, which was called greeting, right? And here I can see that I get a request and a response as a observer. Now, this is interesting because in this stub, on the server side, this interface, or this implementation, or this method signature looks like something that should be invoked asynchronously, right? So rather than having the response on the left-hand side as a return value, you give the response through the observer as a callback. Okay. So on the server side, everything is implemented with async in mind. Okay. Now the client gets to choose whether they want to invoke this synchronously or synchronously. But on the server side, to handle all of the cases, it's implemented as async by default. Okay. So here I can do something like I'm going to print out the request, for example. I can do that. I can create a response, hello response. Now in Java, in gRPC implementation, they love to use the builder pattern. So everything is done via a builder. So what that means is I can get a new builder. I can set the greeting field, for example. And I'm going to say hello plus request dot get name. There you go. And I'm going to build this. And I'm going to assign this to a local variable called response. And then what I can do is to return this to the client. Guess what? I use the observer. So this is called the response observer. And here we have three methods. We got unnext, completed, and onArrow. Okay. What that means is if you do catch an exception, you throw it back via onArrow if you want it to be sent to the client. If you need to send data to the client, you call unnext. Now, even though this is a unary call, meaning the client is only expecting one response, you can actually call unnext multiple times, which is not good, right? If you do it, it's going to give you a runtime exception. But that's the way that this interface works. Now, are we done? So I say, hey, go and send this response to the client. Now, here's the tricky part. You have to call uncompleted as well, so you can close the string. Otherwise, the client will be hung, and it will be waiting for the next thing forever, or until the connection times out, or until you call uncompleted for it to move on. Okay? All right. So far, so good? All right. So now, let's go ahead and implement the server to start this. To start the server is extremely easy. They love the builder pattern, so there's a server builder. I'm going to zoom in a little bit here. I'm going to say server builder.fullPort. I'm going to listen port 8080. And then I can go ahead and register the service that I just created. Basically, you can just give it a new instance of that implementation and build. And assign this to a variable called server, and you're done. Okay. And once you have this reference, what you can do is to just go server.start. And that's going to start the gRPC server in the background thread. And so before I don't want this main thread to exit, so I'm going to say await termination. Okay. And that's it. That should be it for the server, I hope. How many people think this will work? Oh, wow, thank you, yeah. Just for the record, on the video, nobody raised their hand until I said thank you. All right, anyways, I don't want to say. So sad. All right, let's try this. It's unbelievable that this will work, and I agree with you. So let's see. No, actually, it worked. So what happened is the server is in the background thread, and I'm not printing anything, so this is it. So the server is running, I think. All right. So let's go ahead and the server is on. That's a potential too. So the only way to try this out is to implement the client. All right. So if it doesn't work, I gotta fix both things, right? Now for the client, I gotta establish a connection to the server. Now rather than dealing with the TCP connections yourself or even the HTTP2 connections yourself, they abstract everything away and they give you this thing called a channel. So what I can do is to create a new channel, and I do that through a builder, of course. I can do for the local host, port 880, okay? And I'm going to use plain text, just because I'm in the dev environment, I'm not setting up any SSL. And let's go ahead and build it, okay? And I'm going to assign this to channel. Now this interesting part here is that, let's see here, I can do a name resolver, yeah? So this is just point-to-point, right? The client to the server, that's well known. If you do need to load balance across multiple services or multiple gRPC endpoints, well, you have two facilities that can help you. One is called the name resolver, basically helping you to give a service name and identify and return a list of endpoints that the service is being served from. And on the client side, you can then set up a load balancer factory to load balance across the list of endpoints. And you can provide your own load balancing strategy, or you can use the default one, which is more like a round-robin strategy. Okay. So now once you have the channel, you can create a stop to send traffic over the channel. And to do that, I'm going to say gRPC. Greeting service info gRPC. I can say a new stop. Now here's the interesting part, right? At least in Java, when you do a new stop, you have three options. I mentioned before, the server is always implemented asynchronously, but it's up to the client to decide whether they want to block or not. So you can create a new blocking stop, which will block this call and get the return value in where you expect. You can also get a feature stop, which will return you a Java feature, or you can use the asynchronous stop as well. Okay. So for this example, I'm going to go ahead and just use the blocking stop. Okay, and I'm going to assign this to a variable stop. Okay, now we can actually make the call. So I can say stop.greeting, okay, hello request. I'm going to use a new builder, okay. And in here, what I'm going to do, I'm going to set my name to Ray, set age, 18, yeah. Add hobby, so I can say coding, right? I can put back of tricks, coding, not live coding. Okay, something like that, right? So as you can see, it generates all the methods for you. It's all type safe. As long as you stick with it, it's going to generate the right payload for you. And then I'm going to get the response back. Now, because this is a synchronous stop, I can just get the response back. Oh, sorry, yeah, it's a blocking stop, so I can get the response back in the return value. And in the end, I'm going to go ahead and print it. Okay. I'm going to try this again. How many people think this will work? Wow, the same number of hands. Okay. I guess I have to work harder. Okay, so here I'm going to do package and do exec. Let's see. Let me just zoom in here. I'm going to move the response out of the view so you can't see it. I think it worked. I'm just kidding. All right, let's scroll down. Hold on a second. I'm going to scroll down. There you go. Right? So you can see that it actually connected. Wow, thank you. That's too easy. That's too easy. And on the server side, you can see we also generate all the toStrings for you. So you can, if you really want to, you can print this out. So you can see all of the things I entered. Okay? So that's not so hard. That's pretty simple and straightforward for a simple service, I would say. Right? So the next thing I need to do, I think I have until 11:20, right? 11:20? 15 minutes left. Great. So in the next couple of minutes, what I'm going to do is I'm going to write a few more lines of code to basically create a real-time chat server in the chat client in Java with gRPC by using bidirectional streaming. Okay. So I'm going to close these out. If I go to chat server, most of the bootstrapping here is done because I went through the basics already. So the only thing I want to show you is the proto file. Now in this proto file, like I mentioned, if you want a streaming service, you just put stream on the side that you want to stream. In this case, I want bidirectional streaming, so I got stream on the left and stream on the right. Okay, and it's going to generate stub that looks like this line to implement. So I'm going to open up the service implementation here. Okay. Now, don't be scared. Again, every language is a little bit different. This is just how Java works, so it's a little bit more verbose here, but it's fine. It looks perfectly fine. Now, so a few things I want to touch on here is that all the message passing is being done through a callback interface called the stream observer. Whenever the client sends the data to the server, guess what? The server will have a stream observer that listens to onNext. When you want to send the data back to the client, we already saw, you're going to get a stream observer reference, and you're going to call onNext and send it out to the client. So in this case, since this is bidirectional streaming, so what I'm going to do is I'm going to create, basically, return a new stream observer that will have this onNext implementation that's going to be listening to the data from the client. And what I have done here is every time the client connects, I'm going to add it to a list of clients that's currently connected. And so what happens when I receive the message from the client is I need to broadcast it to all of the other clients that's currently connected as well. So for that, I can do, I have a list of observers. I can use a string, and I can say for each of the string, O, observer, and I can do O.onNext, right? And here I can give it the chat message. Now, what the chat message looks like? Well, I typed it specifically to call it chat message from the server so that there's no confusion. So I can do a new builder, right, and build. And I can assign this to the, I can assign this to the variable chat, for example. Now, what goes in here is going to be the data payload I want to send to the client. So I'm going to say, let me see here, new builder, yeah, there we go. So I can say set message, and I'm just going to take the message in that's from the client, okay? And that should be it. So I'm iterating through all of the currently connected clients or observers, and I'm going to send everyone the same thing, okay? Number one. Number two, if the client gives me an error, as all Java developers do, we do nothing. No, I'm just kidding. Here, I should probably remove the observers from the stream. So I do a response observer, right? And I'm going to do the same uncomplete. That's it. That should be the server. Let me just make sure I got all the things closed. All right. That's not so hard. This is bidirectional streaming in a few lines of code. Mostly auto-generated for you by IntelliJ. All right. So let's see here. So I'm going to run the server. Hopefully this will work as well. Okay, very good. Server is on, just like before. Yeah, okay, that's a good sign, given the history. All right, so let's go ahead and implement the client, okay? So now I have a JavaFX client, so just so I don't have to deal with other front ends, right? So what this client looks like is if I do JavaFX run, okay, so basically you can, whoa, what just happened? All right, basically you can type in the name, and you can say hello, and hopefully when you click on that send button, it's going to go to be sent to the server. And hopefully also you're going to see the message payload coming back, okay? So that's the thing we want to implement. So here, I already have established the connection. I'll open up the channel just like before. I created the stub. Now this stub is actually the async stub. So what that means is you actually get the stream observers in both ways as well. So let's make the call. So let's see what that looks like. So chat service.greeting. .chat, sorry. It's going to take in a stream observer, and it's going to return you a stream observer as well. Okay, so chat message stream observer. Okay, so let me just make this a little bit more sans. I'm going to say chat messages to server. Okay, so in this onNext, callback will be triggered every time the server sends the message to me. Okay? So every time that the server sends message to me, guess what? I need to add the message into the view. So what I can do is I just say add. And here I can say, well, what do I need to add? I'm going to add the content of the whatever that's being sent to me. So I have the from field. Okay, I'm going to plus. I'm going to add in the message field as well, the actual text. And that should be it. Now, because I'm running JavaFX, I should be running a platform run later. And what that means is because I need to execute this in the UI thread. So that's what I'm going to do. When I get the error from the server, you guessed it. Let's not do anything for now. When I'm complete, I'm not going to do anything either. Okay? Now, when somebody presses on that button to say, hey, I want to send a new chat message, what do I do? Well, let me make the code. So I'm going to say the send button, set on action, right? And it's going to give me an event. And what I can do is here, I can then make the call to send the data to the server. How do I do that? Through the observer on next, right? And I can say chat message .new builder .build. And let's just make sure I got this all connected up. So I can set the message from, which is the name.getText. So that's what people enter in the name field. And then I can set the message, and that's message.getText. Okay? Whew, live coding. All right. I think that's it. I really think this is it. I think. All right, I'm going to do another poll. How many people think this will work? Wow, still? Okay, more hands. All right. All right, let's try this. Let's try this because I have no idea. All right, so I'm going to do job. Oh, wait. That's not going to work. I need to compile. I need to compile first. So I can do either way. Let me do package and. Oh boy. All right. So just so you know, the source code, if I open it up, so I'm not cheating. Or I'm not like running this off of another server here. Localhost is going to localhost on 409090, which is what I'm listening on. All right, so let's try this. Ray, hello, FOSDEM. First thing. That's too easy though. That's only one client. I could easily have cheated. So what I'm going to do is I'm going to start another one. Okay, and I'm going to zoom in a little bit. Do I see familiar faces here? No, not yet. So what I'm going to do, I'm going to be my manager. I'm going to be Greg, that's my manager. I'm going to say, good job, Ray. All right, it actually worked. Thank you, Greg. Okay, so that's how easy you can use gRPC. Hopefully you see some of the benefits. Again, it works with multiple different platforms. Now, before I close up, let's see, I got 3 minutes. I just want to say there's a lot more than just simple request and response and streaming. Streaming is simple now. You can also set deadlines. So if you're making multiple services calls, and just imagine you're doing a distributed call to multiple services and servers, and one of them is really slow, or some of them is really slow, but you gotta return stuff to the client. Well, what can you do is you can actually set the deadline for the top level service call, and it will be propagated to all the services beneath it. So if the first call takes 1 second, right, and then the subsequent call takes 2 seconds, and your deadline is 2 seconds, currently you have a total of 3. Well, guess what? That entire stack will be canceled. And the server side will receive a cancellation notification as well, so you can close up the transaction cleanly. You can also propagate metadata. So you can do this via the HTTP2 headers, and you can also propagate context. So you can pass the same variables across multiple services within the same boundary. If you need to go across network boundary, then you need to propagate the data via metadata. And that is particularly great because then you can do interesting thing like, hey, putting a security token on the top. Right, you can do distributed tracing with interceptors. You can pass in the trace IDs across all of your services. There are actually really good ecosystems around gRPC at this moment. You can do load balancing and service registries, and you can do some health tracking as well. You can find a lot of this information on the gRPC website. Just go to grpc.io. We want to hear your feedback. We want to get your contributions as well. It is fully open source. Come to the IRC. Check out the Twitter and join the forum groups. And a lot of these things are actually on my GitHub. So if you want to find some of these code, just go to github.com/Satanism, and you're going to see some gRPC Java examples. So thank you very much for your time. Thank you. Any questions? We got time for questions?
Wait, we have 5 minutes for questions. So, questions.
Question number one. Sorry, I see the hands over there first. Yeah. I'm definitely having a really hard time to hear. Sorry. I can't hear because of the auditorium. Could you be able to speak? You'll say later? Okay, I'm so sorry. Oh yeah, so go to the gRPC website and sorry, repeat the question. So how efficient is it? And how do you check, right? If you go to the gRPC website, there's actually a link to the gRPC performance testing suite. So you can actually see the historical performances that they do on the gRPC releases. And that's all open. You can actually just check the link and see it. There were other questions here. Yes?
Thanks for the presentation.
Yeah, thank you.
But I do not buy the fact that it's actually a enabling efficiency of using protobuf. I'm also using protobuf.
Yeah.
And I really can't understand why Google guys resist on shipping a native C binary to the operating systems instead of just writing a native Java compiler for the protobuf. And they did the same
Oh.
with the black box. So I do not buy the fact that it's a deficiency of the name. I think you should really write your own native language compilers for protobuf.
Right, gotcha. Yeah, so I think that there's a trade-off between something that's fully customized. You can even do more efficiency if you go over your own transport, for example, go straight to TCP/IP. But I think there's a balance between the efficiency that you get, the interoperability that you get based on some of the de facto standards out there. So yeah, I absolutely agree. I mean, you can always go more. I'd love to hear more of these feedback afterwards as well. Yeah. Yes, one more question here.
Is it faster and more performant than dbus, and shall we tell dbus?
Is it faster or more performant than dbus? Well, I don't know if that's a good comparison, to be honest. So no comment on that. I don't think that's a good comparison, to be honest. Yeah. Last question over there.
Does gRPC have support, or are there best practices regarding API versioning?
Does gRPC have some of the best practices for API versioning? So yes, actually, one thing I didn't mention is the message payloads, because it's based on polar buffer. You can actually, it's backwards compatible in most part, unless you delete one of the fields. And if you do delete some fields in the same payload, in case you do want to do it, what you want to do is, for example, you don't want to reuse the tags, right? If you use a tag that was deleted in a new field, then the client and the server is going to get really confused. What you can also do is reserve some of these tags so that they don't ever get used again in the future, right? Yeah. So I think that's all the time I have.
You take one more question.
One more? All right, I see over there. Yeah.
So with microservices, you have to be loosely coupled and not have dependencies between the services, right? So with gRPC, how do you address that fact? And your start of the talk, you also talked about not only between the client and the server, and also between multiple services.
Right.
Make use of this. So how do you create a loosely coupled with a strongly typed system?
So how do you create a loosely coupled but strongly typed system? Well, I would actually want to think of them as separate, right? I mean, you can be loosely coupled but still typed, right? Think about in the REST world where you are loosely coupled but not strongly typed. What happens is potentially you will send data or receive data that you never expected. And people are trying to, kind of make that slightly different, right? By having a really good definition language of Swagger. Yeah.
Applications are also built to be fault tolerant, right? So we expect certain things wherein two microservices being developed by two different systems.
Right.
But still we ensure that these are not dependent on each other and fail because of each
Right.
other's mistake. Right?
So what you want is to make sure that you define the service contracts and the payload cleanly in the protocol, and that will be the thing that defines the contracts, and that's the thing that you pass around to different services that needs to consume the service, right? I mean, think about this. It's not many. The IDL, you can think about it, is not much different from, say, a Swagger doc that cleanly defines a REST service, or I hate to say this, but it's like a WSDL, but much, much more complex, right? Okay.
Okay, we can take one short question.
Short question.
Say, short question.
Does it support inheritance?
I'm sorry?
Does it support inheritance?
Let's see. It's mostly composition. Does it support inheritance? It's mostly composition. But in short, yes, in a way. But you gotta compose the objects together. You can also import. So one thing that I didn't get to show is that you can. Oh, not that one. Sorry. For example, you can import types from another protocol as well, and you can reference to that type strongly via strongly typing as well. Okay. And yeah.
Thank you.
All right. Thank you.